Hello class, we're going to continue again on Python list. This is part 5, I think. Okay, we previously talked about this whole idea of passing lists as parameters, and we're going to talk a little bit more about it. Remember, when we pass a list as an input parameter to a function, we're only passing the reference, and because of that, the input variable is an alias to that list. And because of that, if inside the function we were to change that list, the list at the global level can be mutated as well by that function. We saw that in effect, and just kind of as a review, let's talk about that. Actually, today I'm just kind of going to define some words. We call a function a modifier function whenever the input changes. So let's look at this function right here. This is a very simple function. It takes in a list, and notice what happens right here. We sort the list. So the input changed. We call this a modifier function. You know, we have an example here. My list is 4723. We call the function with my list. My list gets sent here, but we sort it. And then when we print out my list actually got mutated, got changed. Okay, so this is an example of a modifier function. A pure function, on the other hand, does not change the input. Let's look at the same function that does the same thing, but it's pure instead. So this is a sorting function, but it's pure. So it receives a list, and the first thing it does, it clones it. And so then we sort the new list, and we return the new list. So that's the function. It's pure. The A list did not change. New list got created and mutated. So watch here. My list is 4723. Even though we call my list call pure function with my list here, because we clone it right away, this does not change. So then we receive the answer, the return value of the pure function here. This will be the sorted list. So then when we print out my list is still the exact same thing, and the new list is the sorted, another list that is the sorted version of it. Now, there's other ways we could create a pure function. Here's another example. And instead of cloning, notice here, this is the input to this function. And this function will create a new list that has just all the even numbers in my input list. So I'm going to start by accumulating a new list. So new list will be equal to the empty list. And then for every item in this input list, if the item is even, then add it to my new list. So you can see here that I'm only modifying a new list. I'm not touching the original A list. You know, I'm using it, I'm reading from it, but I never do anything like list.remove or anything like that. So now I'm returning the new list that I created. And so when we do it right here, my list is this here. I call the even function with this list. And it returns a brand new list that just has the even numbers in it. So what's better? Is a pure function better than a modifier function? Kind of debatable. You know, pure might make it sound better. So if you just looked at this, you might say, oh, definitely, pure functions are better. And they, you know, there's good things about it. One good thing is it's less prone to errors when you write really big programs, because there's never any accidental side effects. The inputs, the objects that you send into the function will not get changed according to pure functions, the definition of a pure function. So you might be able to develop very large programs faster, but at the same time, there are some cons. Pure functions could be less efficient. Suppose we wanted to do the sort method here in the previous one. I don't want to necessarily clone and make a brand new copy of a list. Maybe that list is huge, 1,000,000 elements, and so do I really want to copy all those elements? If it was okay for me to modify the input list anyway. So I would say sometimes, depending upon the function, as long as you know what it does, it's okay for it to be a modifier function. There's nothing evil about it at all. It's not like pure function versus evil function. It's a modifier function, and I would say plenty of cases. Python itself has plenty of modifier methods itself. Sort is a modifier method, so nothing wrong with it. But I would say use a pure function where it's reasonable, and I know that that's a kind of subjective word for you, especially as new programmers. What's reasonable? In this class, I'm not even going to bother whether you wrote a pure function or not. That's all I want at this, for this class, is that you just understand the definition. What is pure, what is not, Okay, another subject in terms of lists. There is a very nice way of creating lists in Python, and it's something called list comprehension. And what list comprehension is again, it's a fancy word. Kind of don't get caught up by the word. It's a fancy way of saying, I'm going to create a list with a single line of code. So it's taking this 4 lines of code and it's turning it into a single line. So let's look at this here. New list is the list I want to make, and so I initialize it to nothing. Then step 1, I say, for every item in my list, in some other list, step 2, if some condition happens to be true, then step 3, append something that is expressed by this expression inside here, append this item to the end of my new list. And so these steps 1, 2, 3 are just right here. 1, 2, 3. And step 2 is optional. You don't need to do it. So let's look at some examples. Square list equals to, make a brand new list. Step 1, for all the x values in my list, there is no step 2 here. So for every x in this list, so for 1, 3, 4, and 6, this is step 3, x squared. Append x squared to my list. So 1 squared, 3 squared, 4 squared, 6 squared. Okay, let's look at the next example. Step 1. For every num in this list, num list here, if it happens to be bigger than 0, then add this to the end of my list. Okay, -4, no, not bigger than 0. 0, not bigger than 0. 5, yes, bigger than 0. So append 5. 2, yes, append 5, or append 2. -1, no. 6, yes, append it. 8, yes, bigger than 0, append it as well. Okay, so again, all list comprehension is a single line way of creating a list that might take more lines of code normally. Okay, so I'm going to have you do this on your own. Pause, and let's go through it right now. I'll just show the answers. All right, class, that's it for today. We'll continue on next time with the final part of lists.